All right, today we've got a story for you that's straight out of a detective novel. We're going to follow a team of scientists as they unravel an incredible chemical mystery and, expose the culprits that are poisoning a really vital river.
So, our scene is set right here at the Loji River in Pekalongan, Indonesia. And look, this is not just any old river. It is the cultural and economic heart of this whole region, which is famous for its stunning traditional batik textiles. For generations, this water has been an absolute lifeline.
But of course, there's a dark twist to this story. The same industry that gives this region its vibrant identity, well, it's also giving the river some pretty alarming colors of its own. And yeah, this isn't the color of life, it's the color of pollution. So the big question for our chemical detectives was simple. What exactly is hiding in that water? To even begin to solve this, the very first step was to treat the river like a crime scene. You gotta establish the facts, right? Understand the full scope of the problem before you can do anything else. Now, the investigation really kicks off. Let's dive into the high-tech tools and some of the really clever methods these scientists used to hunt for clues, like right down at the molecular level. And this is the star of the show. You can forget about a magnifying glass. This is a high-resolution mass spectrometer. You should think of it as this super-powered chemical detective that can identify the unique molecular fingerprint of pretty much any substance in the water. It's incredible. And the way they used it was brilliant, using two main strategies. First up was targeted screening. That's kind of like having a list of your usual suspects and just checking if any of them are at the scene. But then they did something called non-targeted screening. And this is like dusting the entire crime scene for any and all fingerprints, whether you know who they belong to or not. This two-pronged attack means pretty much nothing gets missed. So what did this whole high-tech chemical hunt actually turn up? Well, the results were, honestly, they were staggering. The river wasn't just a little polluted. It was basically swimming in a complex, nasty cocktail of contaminants. Okay, get ready for this number. The team tentatively identified 655 different chemical contaminants. Yeah, not 10, not 50, over 600 unique substances. I mean, that is just an enormous chemical burden for any ecosystem to try and handle. And it's not just the number, the sheer variety of what they found is just stunning. If you look at this chart, you can see the biggest group, that first really tall bar, it wasn't even dyes, it was pharmaceuticals. 129 different kinds, which probably comes from, inadequate sewage treatment. And right behind that, you've got those next bars showing 54 different dyes and even 55 different steroids. It's a true chemical soup. And believe me, the list of culprits just keeps going. Beyond those big groups, they found PFAS, the infamous forever chemicals. They found pesticides from farming, plasticizers. The list goes on. What this really tells you is that the pollution is coming from everywhere, from all sides of modern life. Urban, industrial, agricultural sources, they're all just pouring into this one single river. Okay, with a suspect list of 655, the detectives obviously needed to narrow their focus. And while a lot of those chemicals were invisible, there was one group that was responsible for the river's really alarming appearance: the dyes. This heat map right here basically pinpoints the source. So each row you see is a different dye, and each column is a different spot where they took a sample along the river. And where you see those really dark red blocks, bam, that's a pollution hotspot. And notice how they all seem to cluster around two specific locations, Loji_06 and Loji_12. And guess what? They're both right near industrial areas. And now we get to the smoking gun. The entire investigation started to zero in on this one specific molecule, naphthol ASOL. It's what's called an azoic dye. It's a super potent synthetic colorant, basically a workhorse for the textile industry when they want to create really vibrant colors on fabrics like cotton. And right here, this is the undeniable proof. This chart shows you how much of that exact dye they found at different locations. Just look at that sample site, Loji_06. The amount is it's off the charts compared to every other site. And it happens to be located right next to a batik textile factory. I mean, the connection is crystal clear. So really, the main takeaway is this, and the researchers themselves summed it up perfectly. The data leaves absolutely no doubt that the dyes from the printing, batik, and textile industries are the key contributors to this river's pollution. But, identifying the source, that was only half the battle. The next critical step was to prove just how harmful this chemical cocktail really is. Because it's not just about the color, right? It's about toxicity. Wow, this image is it's devastating. Just take a look. On the left, you've got dozens of healthy mung bean sprouts grown in clean water. They're long, green, vibrant, exactly what you'd expect. And on the right, the exact same seeds, but grown in water taken directly from that industrial hotspot, Loji 06. Their growth is just severely stunted. They're barely even sprouting. It's clear the pollution is actively poisoning plant life. And the science backs this up with a specific measurement they use called the germination index, or GI. Basically, any score below 50% is considered highly toxic. And the water samples from those industrial sites, they scored below 30%. That confirms severe phytotoxicity, which is just a scientific way of saying, yup, it's poisonous to plants. And it's not just plants. The poison affects animal life too. They did a standard test for aquatic toxicity using tiny brine shrimp, and the results were just as clear-cut. So if you look at this table, for toxicity, a lower score is actually much, much worse. It means it takes less of the stuff to be lethal. So water from the middle of the river has a high score of over 960. That means low toxicity. But the water from site Loji_12, right near the industry, it scored just 87. It is highly, highly toxic. So why does one single river in Indonesia matter to the rest of us, to the rest of the world? Well, because in this totally interconnected world we live in, no river is an island. This local story has massive global implications. This quote from the study itself just captures it perfectly. Rivers intertwine everything. They flow into the ocean, and the oceans connect all of us. So the pollution challenges of one nation will inevitably ripple outwards, and they become a shared global problem. And that right there is what makes this research so incredibly important. It helps to fill what they call a research void. You see, most of the pollution data we have comes from high-income countries, but it's often the low and middle-income nations like Indonesia that bear the absolute heaviest burden of industrial pollution. So studies like this one give us a much clearer, much more honest picture of the true state of our waters around the globe. So in the end, the story of the Loja River isn't just about water. It's really about the products we all consume and the global supply chains that bring them to our doorsteps. This river struggle is literally written in the very dyes that are used to color our clothes. And that leaves us with one final, and I think really crucial question. What is the hidden environmental cost of the colors that we wear?